Hi students, this video is on magnetic effect of electric current part 4. In this video now let us discuss the two important points. One is the force on a current carrying a conductor when it is placed in a magnetic field, and another one is about the electric motors. So as we have studied the magnetic effect of electric current, when a current is passed through a conductor, the magnetic field is produced around it. That is, the Oersted discovered this. A current carrying a conductor exerts a force on a compass needle or a magnet. And for this, Ampere suggested that the reverse should also be true. That is, the magnet must also exert an equal and opposite force on a current carrying a conductor, and which was experimentally found to be true. That is, when a current carrying a conductor is placed in a magnetic field, it experiences a force except when it is placed parallel to the magnetic field. The force acting on a current carrying a conductor in a magnetic field is due to what? The interaction between the 2 points here. The first one is the magnetic field due to current carrying a conductor, and the external magnetic field in which the conductor is placed. So because of these two reasons, the force acting on a conductor carrying a current in a magnetic field experiences a force. The experiment showing the force acting on a current carrying a conductor in a magnetic field. Now let us discuss what that experiment which showing what the force acting on a current carrying a conductor when it is placed in a magnetic field. This is what the principle of electric motor also. So when a current carrying a conductor is placed in a magnetic field, the conductor experiences a mechanical force. So this can be demonstrated here. So what is the experimental procedure we can discuss here. So suspend a small rod AB horizontally by means of a two connecting wires from a stand as seen in the figure. So now the place a strong horseshoe magnet in such a way that the rod is between the two poles, and when current is passed in the rod from B to A, the rod gets displaced due to the force acting on the current carrying a rod. The magnet enters a force on the rod that is directed towards the right. As a result, the rod gets deflected to the right side. By reversing the current or interchanging the poles of the magnet, the deflection of the rod also gets reversed. So indicating this one indicating that the directions of the force acting on it gets reversed. This shows that there is a relationship among the what? The directions of the current and the field and the motion of the conductor. So now on what factors the magnitude of the force experienced by the conductor depends here. It was experimentally found that the force acting on a current carrying a conductor placed in a magnetic field in a direction perpendicular to the magnetic field is directly proportional to the current flowing through a conductor. That means when current flowing through a conductor increases, the force experienced by it also increases, and also it is directly proportional to the length of the conductor inside the magnetic field. That means as the length of the conductor increases, the force experienced by it also increases, and also the force is directly proportional to the what? The magnetic, that is the magnitude of the magnetic field, that is F is directly proportional to B. So as the strength of the magnetic field increases, the force is also increases. So from these 3 points we can write the force is directly proportional to L, I and B, that is the magnitude of the magnetic field, length of the conductor and current flowing through a conductor. So now how to find the direction of the force experienced by the conductor. For this we use the Fleming's left hand rule. So by using the Fleming's left hand thumb rule, or it is also called as motor rule, we can find what? The direction of the force experienced by the conductor. So for this what we have to do here, stretch the first three fingers of the left hand, that is thumb, first finger and the central finger of the left hand, stretch in such a way that all three are mutually perpendicular to each other. The first finger is aligned in the direction of the magnetic field, the central finger is aligned in the direction of the current, then the thumb points in the direction of motion of the conductor. So that is, the thumb gives what, the direction of the force on the conductor. So in this way we can find what, the direction of the force acting on the conductor. So thus when the direction of the magnetic field and current is known, the direction of the magnetic force or motion of a conductor can be determined. So this method is known as the left hand thumb rule, that is Fleming's left hand thumb rule, or it is also called as the motor rule. So now what is electric motor? An electric motor is a device which is used for converting electric energy into mechanical energy. Thus, an electric motor is the reverse of an electric generator. There are two types of electric motors. One is AC motor and another one is DC motor. The principle of DC motor is very much different from that of the AC motor. So it is very important point to remember that all the electric appliances like fan, air conditioner, coolers, washing machine, mixers, the AC motors are installed in them. So this is very important point. And what are the uses of DC motors? That is also an important. The DC motors are used in electric fans such as exhaust, ceiling or table for cooling and ventilation. And DC motors are also used for what, pumping water. And big DC motors are used for running tram cars, and small DC motors are used in various toys. So these are some important uses of AC motors and DC motors.